Assalamualaikum everyone. My name is Shazia Bifan. I and my group mate of Frasbert are going to illustrate demons in this session. So let's get started. What do we mean by demons? Are they devils in computer systems? Of course not. A demon is a program that runs continuously as a background process and wakes up to handle periodic services requests, which often come from remote processes. The daemon program is alerted to the request by the operating system, and it either responds to the request itself or forwards the request to another program or process as appropriate. Common daemon process includes print spoolers, email handlers, and other programs that manage administrative tasks. For example, on Linux, the network time protocol daemon is used to measure time differences between the clock on the computer it runs and those of all the computers on the network. A time daemon runs on each of the host computers, with one being designated as primary and all others as secondary. Secondary daemons reset the network time on their host computer by first sending a request to the primary time daemon to find out the correct network time. Daemons also play a very important role in web services. One of the most obvious examples of daemon is the Hypertext Transfer Protocol (HTTP daemon), which runs on every web server, continually waiting in dormant mode until requests come in from web clients and their users. Earlier versions of HTTP daemon would spawn a new process to handle each request. The new process, a replica of the daemon, would fetch the requested content and return it to the requesting client. Then the new process would die. Further, by spawning a new process, the original process could go back to dormant mode to wait for other requests. This approach was used to prevent the original process from getting too busy to service new requests, as a daemon that handles all requests by itself would make a system more vulnerable to hackers. More HTTP daemons, such as Apache, handle requests using threads instead of spawning new processes. Threads, which came into common use well after the first generation of HTTP daemons were implemented and deployed, enable different parts of the same process to run in parallel. The main part of the daemon can wait for new requests, while the other threads handle older requests. Threads require less overhead than spawning a new process, which takes time to accomplish, and the new process needs memory to run. A third approach is exemplified by the NGINX HTTP daemon, which is based on an event-driven architecture operating in a single thread. Requests are handled off to worker processes which constantly run in background. That is, they are not spawned just to handle a request, only to die off immediately afterward. The administrator determines how many worker processes to create. Moving towards the usefulness of daemons, daemons respond to network, hardware, or system requests to perform certain tasks asynchronously. Also, improve system performance. Daemons are designed to perform tasks that would otherwise consume valuable system resources and slow down the overall performance of the system. By running these tasks as background processes, daemons ensure that the system remains responsive and efficient. They can automatically schedule tasks. Daemons are often used to run scheduled tasks such as backup or databases maintenance at specific times or intervals. By automating these tasks, daemons ensure that they are performed regularly and consistently without requiring any user intervention. They can also continuously monitor and manage the system. Daemons are designed to run continuously even when the system is rebooted or restarted. This ensures that critical tasks are always performed even in the event of a system failure or outage. Also, daemons can be used to manage system security by monitoring network traffic, scanning for viruses or malware, and detecting and blocking unauthorized access attempts. By running continuously in the background, daemons can provide ongoing protection. Moving towards some common examples of daemons. First of all, init. This is the first daemon to start up when the Unix boots and it spawns all other processes. Number 2, inetd. This super daemon listens for internet requests on a designated port number and spawns the appropriate server program to handle them. Services handled by iNet include rlogin, telnet, ftp, tok, and finger. Third, cron d. This common daemon executes schedule commands. DHCPD. This daemon provides dynamic host configuration protocol services. Finger D. This daemon is often started by inid to respond to finger commands. FTPD. This daemon is often started by inid to handle file transfer protocol requests. Moving towards background process versus daemon. The main difference in background process and daemon is that background process usually occurs in the context of shell or for job control. Background processes run in any user context. It means that the user of the system can make any change in the background processes, while daemons have no control in terminal and are made to be child of init processes. It means that user cannot change anything about the daemons. What is daemon life cycle? Daemons start at the start of the system and end when the system shuts down. Demonizing a process. What do we mean by demonizing a process? The conversion of a process from its normal state to demon state is called demonizing a process. Here are the common steps to demonize a process. Fork a child process from the parent process using the fork system call. In the child process, create a new session using the set SID system call to detach the child process from its controlling terminal. Change the working directory of the child process to the root directory using the chdir system call to avoid any issues with unmounting file systems. Close all open file descriptors inherited from the parent process using the close system call, except for the standard input output and error file descriptors. Last, write the process ID of the child process to file for future use. Now, why do we need to demonize a process? Here are the few common examples for this. If a process needs to run continuously as a service or server, it should be demonized so that it can run in the background even if the user who started it logs out and terminates this session. Demonizing a process can help with the resource management. A daemon can be started with a low priority and can be configured to consume minimal resources, allowing it to run for extended periods without disrupting other processes or consuming too many system resources. Demonizing a process can also enhance system security. A daemon can be run with a dedicated user account and restricted permissions, limiting its access to system resources and reducing the risk of unauthorized access or data theft. Now, what are the best practices? Logging. Logging is very important in programming. Debugging problems is important in daemons because they have no terminal attached with them. Using syslog or log4c libraries to log events, logging events in files rather than consoles because they can help us in the future use. Security. A daemon is potential security risk because of its asynchronous state. Now what do we mean by security risk? Because daemons run in the background at all times, if a daemon has any malicious code, it can be a result of the hacking for the hackers, and as a result they can hack our system and get our personal informations. Now what are the possible solutions to avoid getting any security risks? Number one, changing group and user permissions for daemon after starts. Change level to non-root user. Dropping unnecessary privileges for daemons such as file access, network access. Conclusion. Daemons are an important part of rendering backend services. By using best practices as outlined, developers can make robust daemons providing essential services to consumer and admin alike. Now that's all for the theory part. Now Fraz will illustrate the Practical use of demons in computer science.
Assalamu alaikum. So, the second part of the presentation, we will be building a daemon. Now, what is a daemon process first of all? एज शजेब भाई ने पहले भी बताया, डीमन प्रोसेसेस कुछ बैकग्राउंड प्रोसेस होते हैं कि जो पीरियोडिकली वेकअप करते हैं ऑपरेटिंग सिस्टम के रिक्वेस्ट पे एंड देन दे एग्जीक्यूट समथिंग द टास्क द डीमन प्रोसेस रिक्वेस्ट टू. सबसे पहले अगर मैं डीमंस का चल एक चीज दिखाता चलूँ आपको, तो वी विल ओपन द लाइनक्स टर्मिनल एंड वी विल रन द कमांड ps aux. ये कमांड क्या करेगी कि ये सारे प्रोसेसेस को लिस्ट डाउन कर देगी जो इसके अंदर पड़े हुए हैं, इस वक्त रनिंग है सिस्टम के अंदर. सो इफ आई लेबल दिस यू विल सी कि ये सारे चल रहे हैं डीमंस. किसी जगह एक नजर भी आ जाएगा, look this correctly. ये देख रहे हैं इसके एंड पे एक डी है, होम टास्क डी. सो दिस रिक्वायर्स कि ये एक डीमन प्रोसेस है जिसकी आईडी 29 है. तो इनफ विद दिस, और हम जगह बिल्ड करते हैं अपने डीमन प्रोसेस को. सो लेट मी चेंज द डायरेक्टरी फर्स्ट. टर्मिनल के इंस्टेंस को कर देते हैं बंद. क्लोज द terminal instance and then go into this folder that we had and then the OS project. Okay, so यहाँ ना दो चीजें हैं कि नंबर वन तो हम ये कर सकते हैं demons.cpp भी, but for this purpose we will build another file, demons2.cpp. Should be created, and yes it is. So let's open it in our gedit editor and start building the daemon. मैं आपको ना साथ साथ वॉक थ्रू करता जाऊंगा कि इसमें लाइक क्या हो रहा है और क्या नहीं हो रहा. तो फर्स्ट ऑफ ऑल हम डिपेंडेंसीज को इंपोर्ट कर लेते हैं. IOStream hash include stream hash include sys/i notify.h. अच्छा, इस लाइब्रेरी को हम इसलिए ऐड कर रहे हैं, दिस विल रेज नोटिफिकेशन इवेंट. ये नोटिफिकेशन इवेंट से क्या मुराद है ये मैं बाद में जब कोड हम करके दिखाएंगे उस वक्त मैं शो करूंगा कि ये क्या है. hash include unistd.h. Let's define a global variable which is the pwd, और ये है हमारे पास open the terminal. This is the pwd. So this is the present working directory. Let's copy that, then go into. So this is our present working directory जो हम नीचे यूज करेंगे अपने कोड के लिए. And let's define some event variables. And let's define another variable which is the buffer length. और ये होगी 1 MB की, almost 1 MB, and multiply with the event size plus 16 bits. So these are the two things. And now let's write a simple file handling function, void log. This namespace log event, and this receives a string event, and it simply writes it to the file. So we will have an OFStream object, OFStream log file, OFStream log file, which will be the directory.log, और इसको हम ओपन करेंगे append मोड में. ओपन करेंगे इसको, ठीक है. And then we'll write a function if log event log file dot is open. तो ये एक built-in function है OFStream class का, which tells के the file is open or not. We will log the event in the file, the event which was coming from this event, and then end the line, and then close the log file. and then close the log file. Else it is going to be an error message. Else it is going to be an error message. So that should do it. Now let's build the daemon function. So first of all, हम दो वेरिएबल बनाएंगे, int fd which is the forward directory and wd which is the watch directory. बेसिकली ये फ्लैग वेरिएबल्स हैं, बट इस पर्पस के लिए ये इंटीजर वेरिएबल्स में भी काम कर सकते हैं, क्योंकि रिटर्न टाइप्स हमारे पास -1 भी आती हैं. तो अगर हम वो यूज करें बूलियन वेरिएबल्स, तो दे कैन नॉट होल्ड देम. So this is why we are using integer variables. ये -1 वाला मैं चीज शो करूंगा कि कहाँ पे आएगी. And this is going to be event of len. Variable event of len. Yes. So first of all हम क्या करेंगे, हम चेंज द वर्किंग डायरेक्टरी. अगर ये नहीं है, क्योंकि यहाँ चेंज करने का मकसद ये है कि डेमन प्रोसेस एसिंक्रोनसली वर्क करेगा. तो for making it work asynchronously, whenever it is called, we have to change the working directory to the one we are watching right now. तो इस वजह से हम इसको चेंज करेंगे explicitly to where the executable is located. And this will be if the ch directory एक फंक्शन है, से change directory वो है iStream के अंदर है, which tells us the directory change. और ये अगर तो directory successfully change हो तो ये 1 रिटर्न करेगा if 1 is true, और ये अंदर चल जाएगा, else ये -1 रिटर्न करता है. Now you might have known कि मैंने ऊपर क्यों fd ये यूज किए हैं. एंड कहाँ हमने वॉच करना है, हमने करना है pwd which is the present working directory. अगर तो सक्सेसफुल है, is not successful, so then we are going to simply copy this error message, then change its text to change working directory. तो ये सिंपल एरर मैसेज चेंज हो गया. नेक्स्ट अप हम ये करेंगे कि हम नोटिफाई के इवेंट्स रेज करवाएंगे. सॉरी, fd is equal to I notify dot init. ओके, अब मैं जरा यहाँ इसका मकसद बताता चलूँ कि क्या है. सो बेसिकली हमारा जो हम वॉच मोड लगा रहे हैं, वी आर वॉचिंग थ्रू a notification. So basically what I'm saying is कि जब भी कोई चीज डायरेक्टली में डिलीट होगी या चेंज होगी या अपडेट होगी या उसके साथ डायरेक्टली में कोई भी चेंज होता है, तो वो एक नोटिफिकेशन आता है. जैसे कि अगर आपको याद हो, मैं यहाँ पे जाता हूँ, अगर यहाँ पे तो नहीं है क्योंकि हमारी वर्किंग डायरेक्टरी है. अगर मैं इसको कर दूँ मूव टू ट्रैश, ठीक है, अगर मैं करता हूँ तो वो एक नोटिफिकेशन इवेंट आता है कि फाइल हैज बीन डिलीटेड या टास्क 3 डिलीटेड अनडू. हम इस चीज को कैप्चर करेंगे जो ये इवेंट रेज हो रहा है, ये जो बार आ रहा है, और इसके थ्रू हम अपना काम करेंगे. ठीक है, और अगर ये नोटिफाई का इवेंट रेज नहीं होता, इफ fd is less than 0, so we will simply speak यही एरर मैसेज. इनिशियलाइज द नोटिफाई. तो हम इसका मतलब है कि नोटिफाई ठीक तरीके से नहीं चलना, एंड वी विल कैंसिल दैट. अब इसके बाद अगर नोटिफाई हो गया, सो लेट्स स्टार्ट द प्रोसेस ऑफ वॉचिंग द डायरेक्टरी. wd will be equal to I notify dot add watch. This is a built-in function in the I notify API. So this is taking fd, the present working directory as parameter, and the file mods. So हम इसे भी फिलहाल दो mods में watch करेंगे, which is the create and which is the delete. और अगर ये अनसक्सेसफुल है, और अगर ये अनसक्सेसफुल है at this point, so this is this again हमारा वही error message, not watch the directory. Close that. इससे पहले हम जरा अपने कोड को भी एक क्विक सैनिटी चेक कर लेते हैं. Let's make a quick sanity check. So E plus plus demons 2.cpp demons 2. I think this should load. Wait, where's something error? We have an error. I think that's it. अच्छा, ये ओके। सो यहाँ पे ना असल में हो ये रहा है कि वो हमसे ये स्ट्रिंग डायरेक्टली पाथ में मांग रहा है एज अ पॉइंटर। सो इट हैव टू पेस्ट दिस शुड वर्क फाइन। चेंज डायरेक्टली पे भी सेम वही आ रहा है। सो इट इज सेइंग कि हम एक स्ट्रिंग का पॉइंटर देना चाह रहे हैं उसे, बट वी आर एक्सपेक्टिंग गिविंग इट अ स्ट्रिंग वेरिएबल। So this should work fine. I think it has worked fine here. And then we are going to run this object file. और यहाँ पे अगर हम ये देखें तो ये output one आ रही है. Like our code is up till this point our code is working exactly right. इसके बाद अब हम daemon build करेंगे. And how we would build the daemon is, सबसे पहले हम daemon process create करेंगे using a fork. Daemon process, and then this would be eid, e process id is equal to fork. तो फोर्क के कॉन्सेप्ट आई थिंक आप लोगों को पहले से आते होंगे, अगर नहीं आते तो यू कैन वॉच दिस बिकॉज वो इस वीडियो के स्कोप में नहीं है। the id is less than 0, close the brackets, and then this will be, अगर तो fork नहीं हुआ so this will be an error, not fork, fork else, अगर तो वो greater than 0 है तो we will return, जो greater than 0 है तो we will exit the daemon process. This is all prepared scale. Now, is point forward, we are going to build the loop which powers the daemon. This is the loop that is going to watch the directory for changes, and this is the loop that is going to log events to the file. Changes in the file. So we are going to write while true. This is going to be a forever loop. So the first part we are going to write in length. Length is equal to read from the forward directories integer buffer document. The directory changes. So basically ये जो length का variable है, this is more of like a holding variable which actually watches, which actually keeps a track of watch events. It isn't actually watching, it just keeps a track of watch events. And इसके बाद अगर डायरेक्टली रीड हो गई है, सो लेट्स इटरेट। अच्छा, डायरेक्टली रीड होने का प्रोसेस ये है कि जैसे जैसे इवेंट रेज होंगे वो इस बफर के अंदर आते जाएंगे और हम इस बफर से एक एक इवेंट पकड़ेंगे एट अ टाइम और उसको देखेंगे कि उसके साथ क्या हो रहा है। नोटिफाई इवेंट पॉइंटर, ठीक है, और किस चीज को टाइपकास्ट करे, और ये टाइपकास्ट करे बफर के उस वेरिएबल पे जिस पे आई खड़ा हुआ है इस टाइम में। ठीक है, अगर तो इवेंट की लेंथ, अगर जो पॉइंटर का इवेंट है वो पॉजिटिव इंटीजर है, इट्स ग्रेटर देन 0, इट इज ट्रू 1 होती है, तो इसका मतलब कि हमारा इवेंट सक्सेसफुली कैप्चर हुआ है, जो भी लाइक हो रहा है इस टाइम पे। मास्क, अगर तो वो इन क्रिएट में था कि फाइल में कोई इवेंट क्रिएट हुआ है, सो Yeah, what we're gonna do, let's name it name event equal to equal to file created and sorry, plus event name, and we are going to convert it into a string. We're going to convert it into a string and then call the log event on this name event. ठीक है कि जो event हुआ है उसको log कर दे कोड के अंदर. And else if ठीक है अगर तो वो हुआ है अगर तो वो हुआ है delete अगर तो वो हुआ है delete हुआ है तो same चीज but for deletion. इसके बाद इस पूरे if के बाद I को चेंज करो इस event name. फाइनली अगर तो ये कोड पूरा ही अनरीचेबल था इसके बाद which is I think this is the int main bracket. Yes, it is the int main bracket. तो इससे ऊपर return 0. इसका मतलब था हमारा कोड अनरीचेबल था. Okay, great. Let's test this, shall we? So हम जाते हैं अपनी इसको अगेन कंपाइल करते हैं. Should compile and Daemons 2. इससे ज़्यादा कुछ भी नहीं होगा यहाँ पे. Let's list down the processes first. तो यहाँ पे आपको ये नजर आ रहा होगा कि Daemons 2 ये वो वाला डेमन है जो हमने अभी बनाया. एंड फॉर द क्विक सैनिटी चेक हम यहाँ पे वापस जाते हैं अपनी डायरेक्टरी के अंदर एंड वी गो इनटू दिस directory.log. इसका मैं स्ट्रक्चर आपको एक दफा दिखाना चाहता हूँ क्या है. ये देख लें. इसमें 13 लाइंस है इस टाइम पे और लास्ट लाइन ये फाइल डिलीटेड है. ये सब मैंने ना टेस्ट रन में डीमंस डिलीट किए थे. लेट्स लिस्ट डाउन अ डायरेक्टरी touch hold.txt. Let's name it demo.txt and let's list down the directory. That directory, wait a second, let's clear the file first. And then cat directory.log. So यहाँ पे ये नजर आ रहा होगा created demo.txt. Let's remove this file rm.demo.txt and then list this command again so you can see create date. So this kind of finishes our demonstration on demons. This is how they work. और इसमें अच्छा एक चीज और भी है. Let me open this and let me remove this executable. Because daemon is all about a background process, right? Daemons 2. And then if we directory.log तो यहाँ ये उसको लैब करेगा. मैं अब अगर कोई चीज टच करता हूँ touch demo.txt and then this command again, it will still record that. क्योंकि यही आइडिया था. क्योंकि अगर वो डिलीट भी कर दिया उसकी एग्जीक्यूटेबल को, the daemon is process is still running in the background. So that marks it all for our demons presentation. I hope it has been right, and if any questions let me know in the comments. Thank you so much.